Welcome to this lesson on the binomial theorem. Before we talk about the binomial theorem, we want to know what exactly is a binomial expression. These are examples of binomial expressions. Okay, now to be a binomial expression, basically there are only two terms inside the bracket. Alright, the term binomial, bi simply means two. Alright, just a bicycle has two wheels, a bipod has two legs, and so on and so forth. Okay, so any expression like this is called a binomial expression. So what does the binomial theorem do? Well, the binomial theorem is basically a formula to expand binomial expansions like this. Now, you should be pretty familiar with a binomial expansion like this one. Okay, now you should have learned how to expand this in your basic algebra expansion. Alright, so how do you expand this? Let us just recap on what you should know. Okay, so a plus b bracket square, this simply means a plus b multiplied by a plus b, isn't it? So how do we expand this? Well, we take a multiplied by a, and that's how we get our a square. We take the a then multiply by the b, and that's how we get ab. And of course, right here we have a b multiplied by a, and that's how we get another ab. So lastly, we have our b multiplied by b, and that's how we get the b square. Okay, so this is why it becomes a square plus 2ab plus b square. Alright, now this is a very basic binomial expansion. Okay, so basically you already know how to expand binomial expansion. The only trouble is, how are we going to very quickly expand binomial expansions, say raised to the power of 10 or raised to the power of 7 or maybe 19 or 100? How are you going to do that? If we are going to do this expansion using the rainbow method, some teachers call it the rainbow method. Okay, if you're going to use it to expand it this way, obviously you know that you sense trouble when you have to expand to the power of 10, isn't it? I mean, you have 10 brackets and you're gonna endless. Okay, you have to do your working endlessly. So there must be a better way out, and the key lies in the binomial theorem. Now, before we move on to the binomial theorem, I think we should spend a little bit of time to talk about the Pascal triangle. So just what is the Pascal triangle? Well, a Pascal triangle is basically an array of numbers, okay, that has got, of course, something to do with the binomial theorem, okay, but it is a very fascinating series of numbers that we'll talk about later on. Alright, first of all, let us take a look at some basic binomial expansions. Okay, now just now we talked about square, right? A plus b square, and then you do the rainbow method, you expand it out, and you get a square plus 2ab plus b square. Alright, now if you do the same, meaning to say, well, after expansion you have your a square plus 2ab plus b square. Okay, and you multiply again by another a plus b, which means that, well, you're going to do the same rainbow thing again, right? You're going to take your a square multiply by a, and so on and so forth. You're going to expand everything. Now you will get a cubed plus 3a square b plus 3ab square plus b cubed. Okay, now if you were to go on doing it for the next term and so on and so forth for the next power, you will get this term. Okay, now the way I arrange it here is to show you that there's a certain pattern that we can actually derive here, and that is what the Pascal triangle is all about. Now, if we were to write down the coefficients of all these expansions of all these terms, right, into the number form like this, so in this case we have 1a and 1b, and therefore it's 1 1, and in this case we have 1a square, 2ab and 1b square, and that's how we get 1 2 1. And of course to the third level we have 1 3 3 1, and that's how we get 1 3 3 1, 1 4 6 4 1, 1 4 6 4 1, and so on and so forth. Okay, now when we write down the coefficients of all these terms into this format, okay, which is of course in the form of a triangle, this is what the Pascal triangle looks like. Okay, now and why is it so fascinating? So just what exactly is the pattern? Okay, now some of you who may be very good at number pattern recognition and so on, you may start to see, hey, there's this very interesting pattern going on. I mean, the most obvious would be what? The first is always a 1, the last term is always a 1. I mean, it starts with 1, end with 1, start with 1, end with 1, and so on and so forth. Now, but what goes on is this. How do we get the 2? Well, it's basically this 1 plus this 1 will give you a 2 here. And how do we get the 3? Well, it's basically this 1 plus this 2 will give me a 3. This 2 plus this 1 will give me a 3. Okay, and this kind of addition relationship goes on and on. Okay, and that's how you construct this Pascal triangle, which simply means to say that, well, the next level, if you want to think about it, okay, you want to work it out, it's actually quite simple. We have 1, of course we start with 1, end with 1. 1 plus 4, the middle number here, this will be a 5. Okay, and of course this will be a 10, and here there will be another 10, here there will be another 5, and lastly ends with a 5. Now what does this 1, 5, 10, 10, 5, 1 then tells us? Well, basically this 1, 5, 10, 10, 5, 1 will then obviously be the coefficient of the expansion for a plus b raised to the power of 5. Right? So if you go on with your Pascal triangle, okay, obviously you can work out the expansion for to the power of 10, the binomial expansion for the power of 10 to the power of 11, and so on and so forth, isn't it? Now, of course, that would be a very tedious thing to do. So, to rely on the Pascal's triangle to do our binomial expansion is obviously very inefficient. So why are we learning the Pascal triangle then? Well, because the Pascal triangle is a very, very interesting array of numbers. Now, not only, okay, the numbers inside this triangle can help us find the coefficients of our binomial expansions, okay, it also has got a lot of little secrets, okay, number series hidden inside this triangle. One of the most famous series of numbers in the world, the Fibonacci numbers, okay, or some call it the Fibonacci series. Alright, it is also hidden inside this triangle. Alright, the triangle numbers, yes, the triangle numbers is also inside this series of numbers. And not only that, this Pascal's triangle has got hidden series of numbers inside it. Okay, it has got practical uses also. Alright, for in the study of combinatorics, which is actually the permutation and combination chapters that used to be in the syllabus. Okay, which is very closely related to the study of probabilities. Alright, and so on. So actually there are a lot more. Okay, so I urge you to go find out more on your own about the Pascal triangle. One of the more interesting thing about Pascal triangle is its origin. There's this very interesting debate that the Pascal's triangle is actually not discovered by Pascal. Okay, it's actually discovered by a Chinese rather than the Western mathematician. Right? So as fascinating as this Pascal triangle is, okay, we are just only concerned about its application and its relevance to the binomial theorem.